The software-based requirements are modest. Windows Server and SQL Server, as we mentioned before. Of course, we need SharePoint Server as well. Between those three, then we pretty much have what we need. You may identify additional software for your installation. Some examples are K2 or Nintex, which allow for enhanced workflow management. You may find other templates or other items that may come in. Those will be identified as you go through your planning process, and you should be very aware of them by the time you get here. Those will help feed your hardware requirements because you'll be looking at those as separate installs of your app servers or all the rest of it. Most of the software features in Windows Server are handled by the Software Prerequisites tool. In a little bit, in the demo in the next module, we'll show you how to run that and how everything can go through. But just know right now that all the different pieces of tracking down the right .NET framework or the right roles for the different server are generally handled by the Software Prerequisites tool. So you should be in good shape there. That's not going to mean a lot of extra work for you. Then we'll look at the systems integration requirements. These are the pieces that are going to have come out of the planning process, and you're going to need to look at what external systems that require integration. One of the things I will mention is that if you don't have a lot here, you probably need to be looking at how you're using SharePoint. Most of the time, seeing a sparse population here means that a lot of your users aren't aware of what SharePoint can do, or maybe you don't have a large system. But normally you want to be able to pull as many systems into the SharePoint implementation as possible, both for user ease and for stickiness of your implementation, so you can make sure that people that are set up for the system use the system and it gives them the best value, and you'll have the best user adoption. One of the pieces that are there, though this seems to be on the wane, are file repositories to be crawled for search. The SharePoint search feature is very powerful. It's one of the most used features inside of SharePoint, and it can be pointed to a number of different areas. If you have file repositories that you've already set up with security, you already have user group accounts, you've already got everything in your Active Directory, you definitely want to take a look at crawling those for search inside SharePoint. SharePoint has the ability to utilize those ACLs, the access lists, so that if SharePoint is integrated in and doing those crawls, you don't even have to worry about users seeing things that they shouldn't, like you normally worry about with file repositories. SharePoint respects what the logged in user has access to, what they can see, and they only see the items that are appropriate to them. So that's one of the very nice things that happens. The databases that require business connectivity services configuration. Again, if you're an old hand at SharePoint, you already know how nice it is to have business connectivity services to do a lot of your integration into your systems. If you haven't used that before, or if your users haven't seen it before, educate them on this. Business connectivity services provides the ability to tie into line of business systems, to legacy systems, to databases, to all types of systems, to be able to surface that information inside your SharePoint implementation without a lot of development, or actually without any development, with just some configuration on how you actually surface that information. Again, with most of it, you can actually work with different identities. So while it's not quite as detailed as the ACL lists for file repositories, business connectivity services can provide different groups of SharePoint users specific views into that data. They can have different awarenesses of what's going on in those, and gives you a very nice way to administratively manage who's got access between the different systems rather than having to make code changes or work with those. So dig deep into the business connectivity services configurations, like databases, line of business systems, all of those, and see what makes sense for you. Other websites to be crawled. As file repositories can be crawled, additional websites can be crawled. For dynamic content, this is a little bit less useful because as things change, you just get a snapshot of what the crawler sees when it goes through there. But if you've got, again, legacy situations, you've got information repositories already in your organization that may be not underneath SharePoint, pointing SharePoint to them, having them crawl that, be able to pull that in and surface that information becomes very valuable and very much a draw for a good SharePoint adoption. And then the line of business systems that may require custom code integration. And this is the most expensive integration piece that you need to do, but know that sometimes you'll need to do that. There may be items that you've got custom logic inside the integration piece. You may need to do different capabilities. You may need to tie in multiple line of business systems that business connectivity services can't do. So dig deep into those, take a look and see what you need to do, how they need to be integrated. When we go into some modules later on, we'll talk about the different options for some of that custom code management. But just know that this may be features, this may be solutions, or this may actually be SharePoint apps. We'll discuss kind of how those come into play. You as an administrator don't need to actually do that, but you do need to be aware of what the implications are from having those line of business systems integrated in different ways and what that's going to mean for your management tool. Hardware requirements. As we mentioned earlier, there are worksheets to help with this. At the end of this section, we'll go over some of the hardware requirements tools that Microsoft has given us, but know that this is probably one of the pieces that's going to be a little bit that will require your art as well as your skill. SharePoint is very flexible about scaling, so your hardware requirements not only can, but probably will change over the lifespan of your implementation. Just be aware of that. Know that that's part of what your monitoring is going to do, part of what your steady state management is going to do. Whatever you've got, whatever you decide at this point, you're not backed into a corner. You know that you can actually change things around as you go forward. That being said, you kind of need to know where to start. So some good rules of thumb are web front ends. If you notice, the hardware requirements has gone up a little bit here. 12 gigabytes of RAM, 4 cores. These can be dedicated servers, they can be real servers, or they can be virtual machines. Again, I mentioned that SharePoint has gone very heavily into virtualization. So if you've got something that's a larger server, maybe a blade server or cloud, you can actually start breaking those cores and that RAM out into modes like this. The database needs to be a little bit beefier. 16 gig of RAM, 4 to 8 cores. If you're working on this, I strongly suggest larger, as we know that SharePoint, everything, all the data goes through the SharePoint. So making sure you've got a nice beefy database means that you're going to be more responsive and you're going to be able to manage more people and be able to service them in a better way. So keep an eye on that one. If at all possible, throw the most hardware you can to the database server. Again, as I mentioned with virtualization, the database can be virtualized, though this is one of the pieces that's still kind of better on real hardware. So choose your balances there. If you do choose to virtualize here, again, it's supported, but do some performance measurements on there and make sure that you're making the best use of your resources. The batch processors. These are basically the non-interactive application servers that you're looking at. These have a little bit more memory requirement for 14 gigabytes and 4 cores. The reason why they're having a little bit more is they tend to be more loaded. You tend to have a fewer of the batch processors per user than you do the web front ends, but they tend to be asynchronous, so they can generally take advantage of more of the synchronous processing. So you tend to build up a better working set, and that tends to help out. So be aware of that. The distributed cache servers, and we'll go into the distributed cache servers in a bit, but these basically help with your management. Again, these are going to be very much like the batch processors, 14 gigabytes, 4 cores. This is going to help you actually keep everything nice and responsive and have nothing really hit the hardware until it needs to. Keep everything kind of in memory. If your company has been looking at Hadoop and in-memory caching, then that's pretty much what you're looking at here to be able to put things in place. Then the piece is network configuration. You've got all this hardware that you're going to be moving around, and you're going to be keeping track, and they're actually going to be synchronized between each other. You need to make sure that your network itself can support it and is not causing any problems as you move through it. Ensure all the ports are open between servers, especially SQL ports. This is one of those pieces that is kind of interesting. Most times this is not a problem, but sometimes, especially as you're working with geographic caching, or if you're actually working with virtual machines that move around between servers, this can actually happen at the port level, especially on enterprises where the network is actually very locked down and very much in control. You want to make sure that you keep track of those ports. Another piece to look at is if you're looking at a hybrid situation where you may have databases on a cloud server, you may have databases that are at another location. You want to make sure that all the farms can actually access all of the database servers and connect with everything it needs to. So very important to kind of keep track of where those pieces are and where your ports are going. You need to have an established load balancer strategy if using server farms, and you almost certainly will end up using server farms or some type of load balancing for production systems. Many times this may be Windows load balancer. This may also be various hardware load balancers or other software systems. This is where, working with your network people, you're going to know what's going on. You're going to know some of the benefits and drawbacks. Are you doing a round-robin load balancer or using sticky load balancers? You don't really need to worry about being sticky with SharePoint. It does have a slight performance item if you're not using your distributed cache servers extensively, but normally pretty much whatever load balancer you want to use is acceptable. Just make sure that it's fitting in with your other network strategy and that everything's kind of in place between what you're going to deploy and what you need to pull back in for later. And ensure the lowest latency possible between your farm servers. The farm servers talk together a lot, moving data back and forth, making sure that, again, with that, if your load balancer is doing just random connections or round-robin connections between all of your different servers, that they all have the appropriate state, and ideally that they're not all having that state move directly through the database. So making sure that those farm servers can talk amongst each other and do so in the most efficient and effective way means that your system's going to be as responsive as possible. When you put together all of these, you're going to have a good story about the software you're going to need, the hardware you're going to need, and one other thing that you'll need to look at is how you're going to balance all of this and some type of test or management server, because all of these pieces will need to be duplicated if you have a test environment, and it's strongly encouraged that you have a test environment when you go into steady state so that you're not testing in production, which is a challenging environment. Even if your developers are working directly on their own SharePoint instances, you want to make sure that group policies or server policies or whatever you've got are managed correctly between where the different content is created and where they're deployed to keep you from actually having to roll back things and manage what you've got in there. So those items to think about. We'll move on into showing a couple of the worksheets and documentation that Microsoft has given us about how to look at these and how to actually plan out our hardware and software strategy. So here we have the worksheet Microsoft has provided for streamlined topologies for SharePoint. If you'll look here, we have some example topologies. Limited deployment, our single server. We can see less than 100 users. We can see some of the hardware recommendations there. Less than 1,000, we're looking at 2 tiers with a redundancy on the front end and batch processing. This should look familiar to anyone coming from SharePoint 2007 or 2010. About 10,000 users, we go up to what we would traditionally call the medium server farm. And you see we got the front end and the batch processing broken off. Again, this should be very familiar, but you can actually see now we're looking at those hardware requirements we talked about for each of the servers, but how they can be configured inside the farm itself. You also see that we've broken off dedicated search servers. Again, for batch processing, we can actually see the more used apps can actually be broken off with their own database servers, with their own crawl servers and query servers, so we can actually scope to what's being used. This is where part of your testing and planning will actually come into play to see how your organization goes into SharePoint, how it's using any particular piece, and allow you to use the hardware in the most effective way. And then more than 10,000 users, we've got the traditional, you really need to look. There needs to be some additional capabilities. You notice it's pretty similar to what we're looking at for the, as we said, formerly medium server farm. Again, we've broken off specialized workloads into their own app servers. We've got the distributed cache and request management sitting in front of the front end. So we've actually got some static caching and some dynamic caching going in front of it to actually help with that. And now you've got those capabilities in place. The worksheet itself goes through and gives you scale guidance for each of the roles themselves. We covered the hardware itself, but you'll actually see inside the worksheet you're getting some consistent latency very low, less than 5 milliseconds, throughput's high, all of those pieces that you need to look at here about how to put things in place. If you look down at the difference between the performance goals, the distributed cache and request management is less than 5 milliseconds. The front-end servers is less than 500 milliseconds, half a second. Now things are getting a little bit SharePointy. Batch processing server latency is high, but these aren't interactive services. They're running in back end, so that's working fairly well. We can go through there. Specialized workloads if needed. Again, very low. These may be supporting batch processing or they may be supporting interactive, so you want to keep that latency low. And then the back end databases, you want it very low because remember, all that system's coming together. You can see we have components and services for database architectures. We'll go take a look at that in just a little bit as well on another worksheet. So now you've got a little bit of information with the database layer with storage groups, breaking out the database into not just different databases, but different database groups, how you can manage it, put it in together, and work with that and actually scale it through. And then down here at the bottom, you can actually see how the Office division is putting together their server farms, so you understand what they're doing and kind of some of the real-world practical applications there for the streamlined topology model. So in this worksheet, we're going to look at traditional topologies for SharePoint. This is if you're coming from SharePoint 2007 or 2010, these are going to be very familiar farm configurations, but just looking for these and how you actually put together your topologies is going to help you with your SharePoint 2013 deployment. If you look at the overview of them itself, you see the service applications are now the application servers. Things have changed a little bit, how the services are going into place, and the virtualization that can be done on these. Again, we move over to topology concepts, and the smallest fault-tolerant farm should look fairly familiar. This is the old medium server farm, or even some of it had crept down into some of the smaller classifications. So you're looking at the web services, the application servers, and then the databases sitting on one database server in the back end. The search optimized farm, which actually has the search capabilities broken out into its own servers to be able to handle the crawling and the queries and all like that while without slowing down your content access and all the workflows and everything you need there. The distributed cache feature coming into play allows you to cache social data so that every time your user refreshes a page, they're not pulling in their Facebook page or they're not pulling in their Twitter feed or all of those kind of things. It also caches the authentication so you're not having a lot of traffic going in and out. And those distributed caches can really help you not just for local response times, but also can help you for your data transfers in and out of your network to be able to not have a situation where you've got more data moving in and out just for keeping Twitter feeds done than you have for production services. You also see the Office web app servers. So if you're actually really working with Office and you've got a forward-thinking group, having those Office web application servers handling the processing, now you can move some of the heavier weight processing off of the desktop, have users able to work with their documents anywhere that they've got a web browser, and be able to handle both those intranet, extranet, and internet situations where your users need to get some work done. Have those in place. You can have everything updated and worked with in that place. And then you can see the request management and load balancing, be able to make sure that any servers that may have trouble or maybe overloaded can be dropped out and be managed. Those being the pieces, now we can step down to the different topologies for the deployment. Limited deployment, you can actually see that here it's going one server, two server farms, and virtual environments where you can actually review how to mimic a three-tier environment using virtualization. If you've got developers who need to be creating their SharePoint development environment but need to make sure that they're processing it in the appropriate manner, using virtual environments to be able to have them enforce those server limits and make sure that they're not they're not doing things incorrectly. It's very useful to have those virtual environments set up differently. The 3-server virtualization farm, again, you can start breaking things out so that if you actually have any software problems or any hangs, the hardware server itself can keep functioning even if the virtual server starts having some problems or health. This becomes very useful for moving things around, especially if you've got good management tools to be able to kill instances and bring them back up in a fault-tolerant manner. So now that you can actually, if you have something happening with a virtual machine that's not working quite as well as you'd like, you can automatically have it removed and refreshed and maybe even re-imaged without it having to worry about any manual processes. And then we kind of go through the 4-server physical, medium farms, and on and on there. Please review all of these. You can actually see a lot of information here about how you can scale out between small and large farms, between how the scaling works, between how all of the different options you can have to put together your SharePoint farm in a very optimal way to give you the most capability, but also do so without breaking the bank or requiring a large amount of hardware that maybe sits idle. You want to be able to manage both your top-end performance needs, but you also want to manage it in the most economical way possible. So, traditionally working with SharePoint farms, one of the classic challenges has always been the database server. How do you actually manage that central point where all of the SharePoint information ends up residing? Well, Microsoft has given us a worksheet to kind of look through and see how the SQL servers can be managed, how they can be configured, and how you can make the best use out of what resources that you have. You can actually look down at this worksheet, downloadable off the Microsoft site, and see that SharePoint itself uses the configuration, the central administration content, and the content databases. But you can also break things out as you need to. The user profile services database, again, can be broken out as a separate server, foundation and server for the search service and applications databases, and all of the different ways that you can put these in place. You've got the service applications database that have the capabilities of breaking things out. As you look through all of these, this is giving you information. I'm kind of moving through it fairly quickly, but you can actually see the sizes of the database you're going to be looking at, how much usage you're going to be working with it, how much data that you're going to be needing with it. So you can actually go through and figure out how you can break these databases out, how you can actually scale what you've got on the various servers that you actually have. So, for example, the apps for SharePoint database, you can see in the center of the screen at the bottom. It's very small. What's that doing? That's basically allowing you a registry or a lookup for knowing what apps you've got on your SharePoint server. Do you need to put a lot of resources on that? Probably not, but you need to know where it is. Can you double up on that with other databases that aren't quite as resource dependent? Yes, now you can actually put those in place so that you can actually make optimal use of your different servers. Again, if you look on your SQL Server 2012 reporting services, the report server TempDB, small to extra large, it depends upon how much reporting you're doing. Normally that's going to be hit fairly hard when you're running reports, and then it may not be used much at all when it's turned off. So you can actually see that usage or those resources are going to vary quite a bit. So this will help you actually figure out how you need to put those in place, what server SQL clustering you need to do, what kind of hardware you need on the back of it. And then you can look down here at the legend itself so you can see with your deployment what you can actually see, how you can cluster them, what you need to put into place. And also those notations down at the bottom can show you what the terms mean. So very small, 100 megabytes or less, extra large, 3 terabytes or more, and all the pieces in between. And the important piece that you're going to be looking at is those the multiple databases. So you can actually break those out not just in different databases, but across different database servers, which means that your scaling becomes much more valuable, and you can actually have a lot more options to make sure those are in good shape, and then you can keep increasing your capacity as you keep moving forward.